So now let's get started on the basics of the R syntax. So the first thing that you're going to want to do is install R onto your system. And so in my specific implementation, when I installed R, I was in the ML environment variable that's part of my Anaconda distribution. When you install it, you're going to want to go and download and install it from the rproject.org, right? And you'll use basically a CRAN mirror to download and install R onto your system. Now, you can use R, we'd seen I actually launched R from the terminal, but there's really no reason to do that. You can actually launch it from the console, and this is what's known as an R session, right? And a session essentially has a workspace that's associated with it. It's like a place where all of your variables are stored, much like a Jupyter notebook. Any variable that we define inside of a Jupyter notebook, well, that's defined in the entire notebook, the entire session that we have. Once we've defined it, it's part of the session. Right? And so the R console works the exact same way, really. We have a workspace session, all the memory that we create and use is saved in there, and it's essentially very similar to a Jupyter notebook. So let's say we open up the R console. We're going to be able to do a couple of different things. And now that we already know Python, we're going to be able to rapidly go through a lot of this R syntax because some of it's the same, and we just have to really highlight what's different without going too far into what you can actually do with, say, like lists or vectors in R, because we already know what you can do with them in Python. Therefore, we can do the same things in R as long as we change the syntax a little bit. So the first thing to notice here is that we can use the equal sign. We can say x equals 10. And in Python, we would say, well, what is the type of x? In R, we say class of x, right? What is the type of x it's going to be? If we were to output this, we were going to see that it's numeric, right? And so a numeric input is something, it's kind of like a wrapper around floats and integers and doubles, all of that. That all gets encompassed into a numeric type that's as part of R, right? Comments, exactly like Python, they're given by the little pound symbol, right? Okay, so let's say we want to explicitly define the type of a variable because we didn't have to define the type of x up here, right? It inferred what it was, and basically R said, oh, well, this is a type numeric. We could have said y equals as integer 10 right here, and that forces R, that when we take the class of y, it forces it to say that that is going to be an integer. Okay, so that's how we can force the data type creation that we want to do. We can do a lot of the same similar things in Python. We would say integer 10 to store it there instead of having it interpreted as a float. There's complex number support. It's right off the bat. This is also available in Python. R has it. So if we said z is equal to 10 plus 0i, anything that starts with a number and ends in I, it interprets that as the imaginary part of a complex number. Right? And if you'll recall, a complex number is just this I is just the square root of -1, whatever that might be. If we try to define that right off the bat, it tries to take the square root of a non-complex number, and it actually will store that as not a number. Right? So if we want to define j explicitly, what we need to do is, hey, take -1, make that a complex number, and then take the square root of -1, and then we'd be able to see, oh, j is actually equal to 0 plus 1i right here. So that's just kind of an aside on complex numbers. So we can also define logicals that are part of R, and they use the keywords true and false all caps, whereas Python used a capital T and a capital F only. So if I set u equal to true and v equal to false, the class of them is logical, and I get access to a lot of the same types of logical operators that I would have in C or C++, or really even in Python for that matter, where if I say u and v, that's false because u and v is not true. U or v would be true, and not v, right? The opposite of false will be true. So it's really easy to be able to use some of these very basic data types. Strings are also native for R. So if I were to define a variable fname equals Eric and lname equals Larson, well, in Python, the concatenation for two strings was just the plus symbol. In R, we're actually going to use the paste function. It means paste these two strings together and return a new string. So if I say paste first name and last name, then I get one string back, which would just be my name. Okay, so those are the very basic data types. There's not too much to go over with those. So instead, let's now look at what are known as vectors in R. So these are going to be a lot of the workhorses. Vectors work a lot of the same way as lists do in Python, but there are some differences. So the way that we create vectors is by using the keyword C, right? So C is kind of like a function which creates, instantiates this vector. So if I want to create a vector right here, I would say C is equal to 10, 5, and 7 right here, and that creates a vector. Now, I can still call class on vector, and what that tells me is the class of vector is numeric, and the length of vector is equal to 3. And here's where we get a difference between Python and R. R explicitly wants all vectors to be the same data type as one another, whereas Python lists, we could have any data type that we wanted. This is going to be much more of a C or C++ extension where everything inside of that array needs to be of the same type, right? So let's say we were to do an operation like this, where we define a vector of strings right here. So these are characters, but they're strings, A, B, and C. And I create a string vector. Then I create a numeric vector, C, which is 10, 5, and 7. And now what I actually want to do is I just want to concatenate those two vectors together. Well, the way that I would do that is just take the C directive, this keyword, and then give it the two vectors that I want concatenated with one another. Now, what R does behind the scenes is it sees that, oh, this is a string, this is a numeric. I need to convert these to be the exact same data type, so it's easy to convert a number into a string. So that's exactly what it does. I get A, B, C, and then I get the string 10, the string 5, and the string 7 right there. So it converts everything to be the exact same number. Now, if I want to index into those, I just use the square brackets. I could say, oh, okay, combined vector at the 1, and that would actually give me A right here. So if I say combined vector at the 1 right here, that gives me A. And that's another difference between R and Python. R is going to be one index. So this is 1, 2, 3, 4, 5, and 6. That's where I access them. Whereas in Python, all of the lists are 0 indexed, as are most programming languages. R is different. So combined vector at the 1 is equal to A. Combined vector, I can actually, this is valid R if I do this here, if I access the combined vector at the 0, but it's not accessing any elements of the vector. What it's actually accessing is the type of vector that this is. So these are all characters, right? So characters are their strings, they're basically in R, are what the data type of this combined vector is. Also, I can't just access, let's say, oh, the second to last element using negative notation. That's not valid in R. Actually, this has a very different syntax in R. What this does is tell it to remove the second element inside of that vector. And so what that actually does is it gets rid of the B right here. However, there are some things that you can do in R that you can't necessarily do right out of the box with Python. Things like giving names to each of the elements that you have. So if I recreate this variable called series, which is of type 1, 5.6, and 3600, and then I actually call names of series right here, and I set that equal to another vector, well, whenever I print out series, it's actually it's almost like it's zipped these two things together where it has provided a name for each of the elements that are inside of those series. And that could be something that's very interesting, and it works right out of the box for R. And that may be something that we want to do, especially many times if we're working as data scientists. That might be something that we are interested in doing, is having named series and even named rows of a column or matrix. So let's talk about conditionals and loops. We'll spend just a little bit of time on this because it's very, very similar syntax to Python. If we want to do logical indexing, it's almost identical to what you would see inside of C or C++, right? We say if 1 equals 0, print 1, else print 2. Scoping is defined not by indentation, as in Python, but as much more traditional programming languages use. It's just by the curly braces that we have right here. So if in the scope, else, and then the print 2 is in the scope. And of course, because 1 is not equal to 0, we print off 2. So in addition to that, if we're looping through things, we can actually loop through things in very similar syntax to we did in Python. It's actually using much more of like a for each statement. So if I were to define x here, I can define x to be a vector that goes from 1 to 10 by saying 1 to 10 right here, right? So this is very similar to like the range function where I wanted range to go from 1 to 10 right here in Python. Then I can select z here and I can say, well, z, I'm just going to set it equal to an empty vector. And now for I in the sequence of x. So what I want to do, what this is basically saying, is go through all of the elements of x that are here right here. And I will enumerate the values of x. So it'll go from 1 to 10, the sequence x. And it'll say if x at the I is less than 5, then I'm going to essentially say, okay, well, this empty list that I had right here is equal to the concatenation of the list that I have and the x at the ith element minus 1. If x at the I is above 5, then concatenate with x at the I divided by 2, right? So what that would actually give me, I would get 0, 1, 2, 3, right, while I'm less than 5 in this sequence. And then I'd get 2.533. I basically get the division of the remaining numbers that are inside of this vector x. Right? Now, there's no reason that I had to define this as sequence of x. Actually, I could have just used this syntax for xi in 1 to 10, and then added that in where instead of x at the I just put xi right here in each of these elements. And that would have given me the exact same vector z on the output. Right? So very, very similar syntax to what we would have in Python, pretty easy to pick up. Functions in R, also very, very easy to define. They are, instead of using the def keyword, we're going to use the function keyword. So we can define function here as we say my function is equal to, and then we say function, and then the number of arguments that we want it to have. We can give those named arguments. These are all named arguments, x1 and x2, and we can give default values for each of those, just like we did in Python. Then we define the scope using curly braces we have right here. And we can say, oh, okay, well, I'm going to define this z1 variable and this z2 variable. z1 is always going to be equal to 1. It's just x1 divided by x1. And z2 will be whatever that second input is squared. And if I don't provide that input, it's just going to be 25. It'll be 5 times 5. Then I can return this vector that I've created. And so my function now, if I call it, will return that. So if I were to call my function x1 equals 2, x2 equals 5, it returns 1 and 25. And that's because x1 was equal to 2, and I actually put input here, x2 equal to 5. Same way as in Python. If I were to say my function equals 2, 5 without actually giving the names, it also returns the exact same vector that I have. And just like in Python, I can actually, if I'm naming the arguments, there's no real set ordering that I need to have those named arguments put into the function. So I could have entered x2 first and then x1, and it would still define everything that was there for me. Okay? So I can also define optional arguments that are part of R, which is not really something that I can do in Python. But in R, what I have right here is, let's say I wanted to define this function 2. One of the things that I could do is say, oh, okay, well, here's x1 is equal to 5. And then I'm going to have this other argument out right here, which is optional. And so if I want to deal with this optional argument, I could say if missing optional argument right here. And basically this says, what this says is like, if this does not have a type, if it was not entered by the user, then do this. Otherwise, if they did enter this argument right here, well, set z1 equal to that optional argument and take z1 divided by x1. Right? Or, if I'm missing that optional argument, well, just set z1 to be some type of vector, 1 through 10. Right? So this is actually very expressive function syntax that we can use in R. And really, that's all of the basic syntax that we need to really just automatically start building things in the R programming language.